So now to carry on with our problem, we want to keep going with this integral. So let's ask what all these things are. K is our constant. K is 8.99 times 10 to the 9. Units are newtons times meters squared over coulombs squared. Cosine theta is the cosine of this angle. So if this angle is theta, then this angle is theta. I'm going to ask, how do we find theta? We know cos theta is adjacent over hypotenuse. Means we need to know what the hypotenuse is. So let's think about that next, and then we'll come back to cosine theta. So we said that the distance between our charge and our point was our distance r. And if we look at our ring, the distance from the center of the ring to our charge, that's the radius, we called that a. So this is a, this is our distance x, that's a right angle. So this r is the hypotenuse of a right angle triangle. So r, just put that part here, r is the square root of a squared plus x squared. So that's something we can fill in for our r. Now let's come back to cosine theta. Cosine theta is adjacent over hypotenuse. So our adjacent to our angle theta is the value of x. Our hypotenuse is r. So we'll say x over the square root of a squared plus x squared. So cosine theta is x over square root a squared plus x squared. Okay, let's put all these things in together here. So ex is the integral of k times dq over r squared, so that's going to be a squared plus x squared. You square the square root and you just get it to the power of 1, times cosine theta, which is x over, and instead of square root, I'm going to write that as to the 1/2. So there's our expression. Let's simplify that. A squared plus x squared to the power of 1 times a squared plus x squared to the power of 1/2 means you add up those exponents. So then that expression is k times dq times x over a squared plus x squared to the 3/2. Now the next step in our integral is let's take the constants out front. So then ex is equal to k is a constant, x is a constant because it's the distance from the center of the ring to the point. So our x comes out front. A squared, a is a constant because it's the radius of the ring, so that comes out front. I'm left with the integral times dq. Now let's ask, what is the integral of dq? dq is a charge element, and this ring is broken up into many, many, many small dq's. The integral of dq means the sum of all those dq's. If we sum up every little bit of charge, we get the total charge, capital Q. So there's the x component of our electric field. And if we want to know the direction, we know that since this is a positive ring, the electric field points away, so it's going to be in the positive x direction. So we'll finish our problem by writing the electric field vector. E is equal to k times x times q over a squared plus x squared to the 3/2 in the x direction I. So there's the electric field at point P due to that ring of charge.